Storing and displaying images. We'll start this video off by asking the basic question, how do computers produce color? Computers produce color using a chemical substance called phosphor. It is a light-emitting substance that can produce either red light, green light, or blue light. And depending on how much light that phosphor emits will determine how dark that light will be or how bright the light will be. Combine these three lights together, then you'll have the ability to produce over 16 million different colors. The exact color that gets produced depends on how much light, how much of each kind of light you produce. When all three lights are shining to the max, you get white. When all three lights are shining to the minimum, you get black. Next, what is a pixel? Right? A pixel is a single dot on your computer screen. Each pixel contains three phosphors, a red one, a green one, and a blue one, and uses all three of these phosphors to produce one single color. So each pixel on your screen is one single color. Combine a bunch of pixels together and you can produce one image. The more pixels on your screen, the better quality image you have. The less pixels on your screen, the lower the quality. For example, the picture on the left uses only 72 dots per inch, or 72 pixels per inch. Because it has far fewer pixels to present this image, it produces a much less quality image than the image on the right, which has a 300 pixel per inch ratio. Next, how does a single color get stored in memory? Well, just as it takes three lights to produce a single color, each color in memory will have three values. An R value, which is short for red value, G value, which is short for green value, and B value, which is short for B value. All three of these numbers can be any number between 0 and 255 inclusive. Put all three of these values together and you form your RGB value. Here's an example. The color dark orchid, which is a special shade of purple. For this color, the R value is 153. The G value is 50, and the B value is 204. Put these three numbers together, and you have your RGB value for dark orchid. To take this even deeper, recall that in memory, we don't store decimal value numbers. We don't use the decimal number system. In computer memory, we use the binary number system. So specifically, this number would be stored for the R value. This binary number would be stored for the G value. And this binary number would be stored for the B value. Put those three binary numbers together and you have your RGB value in binary form, a 24-bit number. This also explains how a single pixel gets stored in memory, because remember, a single pixel stores only a single color. So now that we know how individual pixels are stored, we can now discuss how an entire image gets stored. And we'll start with this very low quality selfie. How would this low quality selfie get stored in memory? Well, first we'd have to determine the RGB value in binary for the far top left pixel. Then the pixel after that. Then get the RGB for the pixel after that. Then combine it with the RGB for this pixel, so on and so forth. We would have to do this for all 100 pixels of this image. Put it all together, since each pixel is 24 bits long, and this selfie has 100 pixels in total, this low quality image would be 2,400 bits. If a low quality image like this would take up 2,400 bits in memory, can you guess how many bits this kind of image would take up in memory?